we will be discussing about YouTube system design. And obviously you guys are watching this video over YouTube and I have uploaded the video over YouTube. So there are multiple things happening behind the scene, and this will be one of my so far complex design that I have kind of thought of, and it was very interesting. So this will take some time to digest, but bear with me. First of all, in case you guys have not experienced how the upload journey looks from a user side, I'll tell you. There is a YouTube studio section. In there you will select the upload button. Once the upload button is clicked, a widget appears. You have to basically drag and drop your file over here, or you can upload from computer like the normal wizard way. Once that starts, there are 3 back-to-back steps that start happening. First is the upload, next is the verification step and encoder step. So the first thing is the encoder. It kind of looks like this, and then is the verification step. This starts happening the moment the upload is complete. It's sequential. First the upload gets completed, then it starts the encoding step, and then it starts the verification step. And apart from that, there is also, once the video upload has been complete, there is also a widget where you have to fill like the title, description. You have to select is it for kids or not, and then like other things on extra information like copyright or not, all those things, like all the meta information. And finally also the release, like do you want to make it public, private, unlisted. There are a lot of metadata information which you parallelly keep filling, and this keeps happening in the background. This is the entire journey from my side as a creator when I upload the video. And for you guys, what happens? You guys open YouTube, there's a search bar, you guys enter your name, or in case you don't want to search, there is the recommendation section in the home page feed. You select in one of the videos, a new page opens, you have the player open up, and what you see is you keep select the play, and slowly it keeps loading over here and video starts playing. You kind of feel an uninterrupted streaming facility where the moment you click on the video, the page loads and the video player starts playing the video. It does not wait. It gets the initial sequence and starts playing, and as and when the seeker gets moving forward, some part of it is preloaded and buffered up, which starts playing. So that is the entire experience, both upload side and the viewing side. Now let's condense it down into business requirements. And these are our business requirements. One is user is able to upload the videos and user is able to watch and stream the videos. Now it looks very simple on the surface, and trust me, this is simple when we start with our first principles. So for example, say we have to upload the videos. If I were to immediately start thinking about it, there's a client, there is a load balancer over here, and then there is a upload service. LB plus API gateway, we have already discussed about it in today cloud providers provide it in the combined format, and then this is our video upload service. What we would be doing, first thing, we create a upload request to here, and what will be our API endpoint for it, I'll write that down as well. It would be something of this sort format. API videos upload initiate. Having said that, right now the API verb or noun is not the main concern. It's more about what happens. Generally, in a very basic level, if you're not aware, we'll be doing a post request, as I have already mentioned. There will be the file content of it and the bytes, chunks of bytes, and we are done. But that is not the ideal way to go. First of all, there are 2 things. One, you will be using a combination of load balancer plus API gateway. So there will be firewall rules coming into picture, and that itself will limit the post body size to like 10 MB. That's it. Your general video size could be around easily on an average 500 MB or more. the video upload size. I have personally uploaded files of 1 GB file size or more. That means it's not the way to go. You have to do some kind of chunking, like part by part the file has to be loaded. And that is where the concept of multipart file upload comes into picture. You will hear this term, multipart file upload. So we kind of change the structure here a bit. Now that I have cleaned up the space, what we will introduce is that obviously at this point we know that our files are stored in blob storage. We will bring something called pre-signed URL. I'll discuss in a minute what this is. Once a video upload initiate request has been created by the client, video upload reaches out to S3, gets a pre-signed URL, forwards it to the client, and then the client will directly start an upload into the S3 bucket. Now why pre-signed URL and what this pre-signed actually means over here? So think it in this way. Say you locate every resource using a URL. So this is like the bucket 1 v1 where the file has to go. This is the indicated by the URL, but then you don't want anyone to get access to it, so you sign it. And sign is basically saying that only one who has access to the URL by the signing mechanism can access this bucket and keep their content. And by default it also has a TTL, so after some time this pre-signed URL expires. That means say any other user can anyways not, even if they have access to this signed URL, they cannot upload over it. And if client 1 also does not upload within the TTL time, it expires, and then this bucket is, or this resource is no more reachable to upload. And the other part is the file upload happening over multipart. So S3 itself will provide the chunking strategy. That means it will understand and it will say that this is your 1 GB file, so kind of chunk it into bytes, like 10 bytes, 10 MBs each, and then keep chunking. And then it will keep sending those chunks over the network, and it will then reassemble it. Any of the chunks if lost, then again it will ask for that chunk, and then the entire file will be accumulated. That is why you see the file upload happening so fast. But I will not be going into the reassembling part of this and this strategy. We can deep dive it later in some other video. Overall, what I want to say is the major part of this design here right now is introduction of a blob storage, pre-signed URL, and a direct upload. But this is not where life completes. I will be again decluttering the board. Now that the board is cleaner, this is one aspect of this. As I already said, there were two things. One was the upload, then there was the encoding, and then there was this verification. Our upload step is complete. What is encoding and why that is coming into picture? Well, as I said, we are watching and streaming the video. So let's say this was our entire design so far, and let's say a user has to now read the or that is play the video. What they will do? So the client is over here via the API gateway. They have to just, this is the service or like API server. I'm not naming the server right now because there are much depth to it, but say it's the same S3. So I make a request that I want to like play with the video ID. Is that more than enough? Because say I have the 1 GB file with me, I will directly then start downloading it, and then that means first my file or media player has to wait for the entire 1 GB to get downloaded, and then the play will start. And let's say my bandwidth is limited enough, either the 1 GB file download will take a lot of time, or otherwise the connection will drop in between. That is not how YouTube works or any streaming device works. That is what we have observed. The moment we start the video, it starts playing. That means initial chunk of this file has already come to the player. So that is where the chunking is working. You can literally hover over this in YouTube while uploading a video and it will say the chunking in action. So again, let me clean the board a bit to discuss about what this chunking is. It's a pretty interesting topic. So in today's world, what we follow is the concept of adaptive bitrate streaming, adaptive bit rate, and this is the streaming. And for this to be realized, as I said, we have a client which is given the full flexibility to understand that what its actual bandwidth is and what its resolution capacity is. So bandwidth, resolution capacity. Based on these two parameters, it can ask the server, okay, so now that my bandwidth is supporting, let's say, let me mention 480p, 720p, 1080p. Let's say there are chunks here, and similarly chunks here. And it's all the same video. So this will be my video symbol. Now, if my bandwidth initially starts and says that, okay, I have enough to go for 720 pixel, then the client asks for this. Let's say this chunk is served, this chunk is served, they are sequential in nature. So after some T1 chunk, T2 chunk, these are like timestamps. So if you have this long video, the chunking will happen at, let's say, T1, T2, T3. Right now, this chunking mechanism and strategy is beyond the scope of the current design that we are talking about. This is just a discussion we are having to tell you that what new services will come into the actual design system. So bear with me again. Now next part is, let's say at this point, we can see that there is some choking happening and that T3 is unable to get loaded because of the current bandwidth and resolution. What it will do according to its algorithm, it will say that, okay, 720p is something I cannot afford, I'll go towards 480p. Or it could be the other way around. It has enough bandwidth, like it has got a boost, that it can opt for 1080 as well. So it can ask the next chunk from 1080's T3. And that is what the entire algorithm is all about. So if you go and check it, I have mentioned it over here. This entire bit is actually stored in the format of M3UIT. Now this is under the HLS or dash. So dash is the open source format of this adaptive bitrate streaming, and HLS is the proprietary provided by Apple and Adobe in combination. So what we do is we have this, it's like an index file. So we call for the master.m3uit. Then client sees the available renditions like 144, 240, 480, all of them as I had mentioned over here. Next, for now, we start with 720. It's not necessary. It depends completely on the bandwidth. I have taken optimal point where from 720 with M3UIT, playlist.m3uit we start. Now it has these segments, segment 01.ts, segment 002.ts, all these things. If the network is good, it will switch to 1080 playlist and it will start asking for the next segments from there. And what happens over there as well, like you think it is only segment 01.ts, it's not like that. There is the entire thing that first the format, it will be 720p, then it will be the play chunk, then it will be the segment 01.ts, and most probably it will be getting served from an S3. So you will see something like the base URL and then the 720p and all these things. That is how this entire thing will happen. Now we switch to 1080 playlist, and if the network is bad, it will drop to switch to 480 playlist. This is how your textbook based HLS dash adaptive bitrate streaming works. There is a reason why I said it is textbook based, because YouTube follows the same process, but there is a catch to it. We'll come to the reading, or in this case, which we say as watching stream. There is some caveat to it, which we say as SABR. Instead of client controlling it, YouTube does the server-sided adaptive bitrate. That means client gives its information of bandwidth, resolution, and some more meta information, and then the server decides what is the adaptive bitrate that the client should work on. We'll come to it later, but I will start introducing more system design individual concepts over here, and after that we will go to the watch and stream path. So let me again bring this to a new board and start working on it. So now that we have brought the entire thing into a clean page, the important thing is we have come to know that there is something called transcoder. Sorry for the pen color. And the main thing is video upload has to now forward to the transcoder. But think about it. There are so many video uploads happening on a daily basis. Just to give a brief idea on the number, there are 5 million daily active users, out of which 10% of them upload a video every day. So 5 into 10 power 6 into 10 into 10 power minus 2. What would it look like? Somewhere around 5 into 10 power 5 video uploads are happening on a day, on an average. That means there is a huge workload coming and we cannot just engage and block it. So the first thing that you guys have to keep in mind is this cannot be a direct, like first a video upload happens from the S3 side, it gets completed. And also, how is it getting completed? S3 has a notification mechanism. Either S3 or GCS, whatever is the cloud provider here for the blob storage, irrespective of that, S3 will be notifying back that the upload is complete once it is done. So what will happen is, let's say there are even 2 transcoders scaled up, but still it will be waiting until the one video upload is completed. We don't behave in that way when there is such a huge workload. We introduce something called job queue. This will be your JQ, and because there is already a job queue in picture that we have placed right now, there will not be a direct transcoder. There will be a job manager. There is a reason to it. So now I'm introducing some more components and then I'll start connecting them. Let me clear the board a bit more. Now that it is much clearer, as I was saying, it will start submitting jobs into the job queue. There are different jobs over here. Maybe a bit of color change can help. Now the next thing is, as and when I will introduce the scaling it bit over here, but job manager will be understanding the job queue. It will pick up from one of the jobs from here, and it will then, is our video metadata. The reason I'm introducing this table over here is this part was only, and the rest of the arrows that I will be drawing, this is only related to one aspect of it, that we are uploading the video and that is getting processed. But there are other aspects as well: title, description, content policy. So all those things that will also be made as a separate request by the client, which the video upload will be entering over here. But we are also managing the job. So there will be a status of this entire video. I will be giving the schema structure detail in some time, but consider there is some status in which we are saying it is processing, it is chunking, validation, or whatever different status is there. So the job manager will also at times interact with this job video metadata DB. I'm underlining it. Next, once this is done, there will be an encoder queue over here, because again, encoding is a heavy task. At the same time, the job manager has to keep dispatching this work. So it will start submitting jobs over here, and encoding worker can pick up, and also based on how much the queue is getting loaded up, more and more auto scaling can work into picture. And once encoding worker does its job, and by encoding we strictly mean that chunking it properly, even these chunks will also be stored into its dedicated encode video storage. This is also an S3 only. I'll name it as encode video store, and it will keep putting the encoded metadata over here. Now the next part is, after this there will be a media processing. So media processing, I will be making it like a dotted, which has multiple things in parallel. One will be thumbnail, The other would be validation worker, which is content validation. Things like checking for copyright or adult content or not, or if there is AI generated stuff. There are a lot of things, and there are other parallel workers also. So before this is also picked up, there will be another queue. This will be media processing queue, and from here parallelly different workers can pick it up, and they will also scale accordingly. Now obviously the board has become a bit hectic. I will just clean the diagram. After clearing the board, now that you can see the flow, after job manager, I'll be using my highlighter over here to give a brief understanding. Job manager is sending it to the encoder queue, and from the encoder queue it goes to the encoding workers, which auto scale, and once the encoding is completed, it stores into the encoded video store. Then for further processing, it sends to the media processing queue, from where parallelly things are picked up like thumbnail generation, validation, and any other metadata like content abuse or any other stuff. All of this also needs to be notified. So that means there is one more component that we have to draw, that is job update. So this is the job update queue. All the tasks that are being done by different workers, even the encoding worker, they will keep submitting their update, and then the job manager keeps reading this as well. And now we have the complete system ready from terms of upload. That means if we again walk through the entire flow here, we have the client over here which is making a request to upload, and initially starts with video uploading request. So the server will reach out to S3, get a pre-signed URL, and it will forward it to the client again. Client will start its upload to the S3, and once it's complete, S3 will send a notification to the video upload. At this point, the video uploading is complete. Obviously here also it was using multipart, using a put. Once that is done, then video upload will send it to the job queue, and at the same time there will also be another request sent by the client related to filling up the metadata for the video. At this point, let me also write what would be the few things of schema structure of this metadata table. There will be ID, there will be name, that is a title, description, video URL, all these informations, and then there will also be a status. So once these all are done, from video upload it will be sending it to the job queue, and from job queue job manager will kick in. Job manager will then take this job, it will start working on the status part of it. It will first put it to the encoder queue, then from encoder queue encoding worker will pick it up. It will be chunking it up as per this strategy, and then storing this into the encoding worker and S3, and at the same time it will be taking it up and putting it in the media processing queue. Once it's completed, from media processing queue different workers will pick it up again, like thumbnail, validation, others, and all of these in their task will start updating into the job update queue. Job manager is reading both job update queue as well as the job queue, and accordingly it will start making the updates into the status queue. Now obviously there is a reason why I have kept a job queue completely separate from a job date. The job which is put over here, it will have a different kind of a payload, and it completely means new jobs in action. And these are the already running jobs which have at least gone past the video upload surface and have gone via the encoder and going into the different part of the worker state. So that's why they need a dedicated job update queue, because we can apply a revalidation logic separately for this queue and a separate revalidation logic for job queue, and that is why we have two different queues over here. This completely, there is a lot of abstraction actually over going here. If you read the textbook, that is what I have been seeing so far. This entire thing in itself is actually conveyed through a directed acyclic graph. Obviously, it looks like a DAG at this point, but there are a lot of things to it. Job manager being a very key player, it has to manage a lot of heavy lifting. So there will be a pre-processor step, then a DAG scheduler, resource manager, task workers. Obviously, we can see the individual task workers over here. But then how it has to be scheduled, because transcoding in itself is not a very easy task. There is the video part of it and audio part of it. Both has to be transcoded and accordingly stored. So there will be a DAG coming into picture, a DAG scheduler, and then it will be scheduling it. That is not the scope of the encoding itself. Then we have to deep dive into each of these workers and see that how they are optimizing each of the separate tasks. But now, having said that, we have successfully done one aspect of the business requirement. User is able to upload the videos. Now already I have given a very brief on how the watch and stream of the videos will happen via this request, but it is for a textbook based HLS and dash. It's very easy, but from a YouTube scale, they don't directly leave it on the client to go and fetch. Obviously there are reasons, and we will discuss about it in the new page. And we knew that there is a client. If it were an ideal world, you can just directly, as I had already repeated earlier, keep a load balancer plus API gateway, and there is a S3 sitting over here, and there will be a serving point over here. Client will ask from it, client will reach out to the metadata DB, it will check what the S3 is URL is, it will give it back the response, and then client will start loading it from here. And it can do it via this exact mechanism. It just needs the master.m3 UID file of the HLS. That's it. But YouTube does not follow this concept. It follows the concept of SABR. There is a very important reason: server-sided adaptive bitrate. One, YouTube wants a bit control over how the user is experiencing the bitrate streaming. And they want that player to also go through a lot of things like the add decision service, from exactly which part of the CDN, that is the media delivery edge, is the video coming, what are the geography policies working in picture over there. For example, a content is allowed in India but it is not allowed in some other parts of the world, or vice versa. That is where a lot of control they want from a server side. So what they are doing instead, there is this point which we will say as player metadata service. It will reach out to a few places. It will reach out to the add service. Then it will also reach out to the token service. Why token? Again, this is a common issue with the textbook based HLS, is that the moment you get a master.m3 UID file and then you finally resolve it into the correct S3 URL path or whatever file resource it is, anyone with access to it can start abusing it. That is, they can start downloading those resources. But YouTube does not want that to happen. So it needs to control. So there will be a token service as well. So the moment the request goes to the player metadata service, it will first reach out to add data service to understand exactly this particular user from the user profile. Are they ad, or to show them ad or not, like they are subscribed to premium and all those things. Next, it will go and reach out to the token service and generate a signed playback token. Then it will reach out to the CDN routing service. Why? Because in our globe, this is my globe, there is Asia, there is Europe, then there is this entire America. Sorry for the drawing. This is North America, South America. This is Africa, Australia. Point is, geography located, there will be CDN. Now, from where did CDN come into picture? S3 is not the correct place from where the serving should happen, ideally speaking. S3 is like a data store. But then, all these content should be hot loaded into the content delivery network. They are more optimized, and CDN expects its own dedicated video discussing why CDN is CDN and why it is required in today's world for doing a very high availability and high bandwidth content distribution. So assume that it has been loaded into CDN, but which CDN? From which geography? That is what CDN routing service will provide. So once the CDN routing service responds back, then it will generate back with a player response. It will be looking something of format. It will have a format. It will have the SABR URL. Same like here, which we were seeing. This was the HLS URL. Instead, we will have an SABR URL, and along with it, there will also be the token. Now, this entire thing is our CDN, which I will say as CDN, but will also say is as media delivery edge. Content is lying over here in different bits and streams and whatever. What will happen? The client will directly reach out to it along with its token, which I had already pointed out here. It will validate using the token that is it authenticated. Once done, it will start providing the bits. But then I also said the client is only reaching out to it. It's not asking directly for the bits. It is rather giving in terms of telemetry that what are its buffer, bandwidth, dropped frames, etc. along with playback state. All these you guys can check when you are doing a network call when YouTube is playing. It is actually giving these information back to the server, that is to this. Now the media delivery edge, it doesn't have its own brain. It will actually ask the ABR engine over here, which YouTube has its own proprietary. It will give this information back to the ABR engine and it will run its own fine-tuned algorithms to reply back to the client with the next set of bits that the client has to play. And that is how the entire thing will work. Just to make a clean sense of what is happening, I'll again clean the board a bit so that it looks much better. And here we go. This is the client, ask the player metadata service. This has reached out to the ad service, token service and CDN routing service. Obviously, it has got response of the token, the pre-signed token, the ad service information from the metadata user's profile, and from the CDN routing service on the best CDN it has to reach out to. Once it has got all the information, it has replied back to the client with the exact resource URL of the SABR. So SABR URL plus token. Now it will reach out to the delivery engine. This delivery engine will first use the token service to authenticate if the user really has access to watch this video via the token. Once that has been resolved, the client also in its post request will send this information. It will keep sending it. So the URL path and some meta info like buffer, which I have already written over here, bandwidth, playback state. Playback state means at which timestamp it is, or the chunk ID, all these things. This information delivery engine will give to the ABR engine. ABR engine will decide that what will be the next chunk of which resolution that has to be provided, and using that information it will reach out to the CDN and fetch that information and again pass it back to the client over here. This completely resolves the entire stream flow. Obviously there are a lot of places that have been abstracted out completely, but the main intention of this entire video was to give on what is happening behind the scene in a simple scenario like YouTube, where we are just uploading the video and then we are also watching the video. Now just to give a scale and sense of why everything cannot be placed in the CDN, these are priced very sensitively based on how much content is extracted out of the CDN. So not every video can be placed in the CDN on demand. What is a better optimized technique is keep some part of it in the CDN for some geographies, understanding which video is watched the most, and rest of the videos, because YouTube has found out that it's a long tail distribution. Most of the videos come in the long tail where they have views, but they are not into the place where it should be loaded directly into the CDN if needed. These have spikes in the views. They will be the ones which will be creating a lot of issue, and that is where they have to go in a flexible hybrid approach and load the content some into the CDN and some they will keep it into the delivery edge itself. That is into the actual bit storage S3 here. So it can load it from here directly, like via the CDN path. If it is not present, it will fetch it from the S3 and then hot load into the CDN, and accordingly the entire serving will happen. So yeah, this was and has been a very big video for me, discussing a lot of different points that we have gone through. I know that there have been a lot of places I have abstracted out, so I am expecting a lot of discussions in the comments and what doubts they have. I'll try my best to kind of resolve them. So looking forward to the next topic that I will be discussing, or anything that you guys have in demand. Alright, so please subscribe the video so that it gives me inspiration to upload more such content, and do like and share.